Solve the simultaneous equations 3x minus 2y plus z is equal to 9, x plus 4y minus 5z is equal to minus 17, 2x plus 3y plus z is equal to minus 2. We start by deciding which of the three letters is easiest to eliminate. Then we eliminate this letter from the two pairs of equations, leaving us with two linear equations and two unknowns. Z appears to be the easiest letter to eliminate. And the reason for that is in two of the equations we just have a single z. So we have z minus 5z and then another single z. Whereas the y's all have different coefficients and the x's all have different coefficients. So we will get rid of z from the first and second equations and then from the first and the third. So we're going to take the first equation, which is 3x minus 2y plus z is equal to 9, and we're going to multiply it by 5. So 3x by 5 is 15x, minus 2y by 5 is minus 10y, z by 5 is 5z, 9 by 5 is 45. And then we're just going to take the second equation as it is, x plus 4y minus 5z is equal to 17. So x plus 4y minus 5z is equal to 17. So that 1 represents the first equation and that 2 represents the second equation. So now we can see that we have plus 5z minus 5z, so they'll cancel out. So 15x plus x is 16x, minus 10y plus 4y is minus 6y, 45 minus 17 is 28. So then we can simplify by dividing this entire equation by 2. So 16x divided by 2 is 8x, minus 6y divided by 2 is minus 3y, 28 divided by 2 is 14. So we get 8x minus 3y equals 14. So now we're going to take the first and the third equation. So the first equation, so this one represents the first equation, is 3x minus 2y plus z is equal to 9. So we get 3x minus 2y plus z is equal to 9. And then we're going to take the third equation and multiply it by minus 1. So the third equation is 2x plus 3y plus z is equal to minus 2. So 2x multiplied by minus 1 is minus 2x. 3y multiplied by minus 1 is minus 3y. Z multiplied by minus 1 is minus z. Minus 2 multiplied by minus 1 is 2. So now we notice that we've plus z minus z, so they'll cancel. And then 3x minus 2x is x. Minus 2y minus 3y is minus 5y. 9 plus 2 is 11. So our equation is x minus 5y is equal to 11. So now we have two equations in terms of x and y that we're going to solve simultaneously to find x and find y. And then when we've done that, we can find z. So now we have two simultaneous equations in two unknowns, x and y. So we can solve these in the usual way by getting rid of y. So our equation from the previous slide, where 8x minus 3y is equal to 14 and x minus 5y is equal to 11. So we're going to solve these simultaneously. So the 4 represents this equation and the 5 represents this equation. So what we're going to do is multiply equation 4 by 5. So this equation, we're going to multiply each term by 5. So we're going to say 8x multiplied by 5 is 40x, minus 3y multiplied by 5 is minus 15y, and 14 multiplied by 5 is 70. And then we're going to take equation 5 and multiply it by minus 3. So x multiplied by minus 3 is minus 3x, minus 5y multiplied by minus 3 is plus 15y, and 11 multiplied by minus 3 is minus 33. Now we notice we have minus 15y plus 15y, so they'll cancel. And 40 minus 3x is going to be 37x, and 70 minus 33 is 37, and 37 divided by 37 is 1, so x is equal to 1. So then we're going to take one of our equations. I'm going to take equation 5, which is x minus 5y is equal to 11, and we're going to swap the x for 1 because we have x is equal to 1. So we get 1 minus 5y is equal to 11. So bring the 1 over the other side, it becomes minus 1. 11 minus 1 is 10. Let's get minus 5y equals to 10. And 10 divided by minus 5 is minus 2. So y is equal to minus 2. Now we return to one of the original equations to find the third unknown, which is z. So we're going to take equation 1, which is 3x minus 2y plus z is equal to 9. And we're going to swap that x for 1, so it becomes 3 multiplied by 1, which is 3. And we're going to swap that y for minus 2, so it becomes minus 2 multiplied by minus 2, which is plus 4. And the z stays the same, and the equals 9 stays the same. So 3 plus 4 is 7, and 9 minus 7 is going to be 2, so z is equal to 2. So our final answer is x is equal to 1, y is equal to minus 2, and z is equal to 2. So this is the same question, but just done slightly differently. So I've taken the three equations and I've labelled them A, B and C. So I'm going to take B and C, the second and third equation, and I'm going to try and eliminate the z's. So B is x plus 4y minus 5z is equal to 17, and C is 2x plus 3y plus z is equal to minus 2. So what I'm going to do is multiply equation C by 5 so that my z's match up with different signs and I can cross them out. So I'm going to keep equation B as it is, so I'm going to write that down here. And then I'm going to multiply equation C by 5. So 2x by 5 is 10x, 3y by 5 is 15y, z by 5 is 5z, minus 2 by 5 is minus 10. Now I can cancel out my z's. X plus 10x is 11x, 4y plus 15y is 19y, minus 17 minus 10 is minus 27. So now I have one equation in terms of x and y. Now we need to get another one. So next time I'm going to take equation A and equation C. So taking equation A and equation C, the z's are already the same, so I've plus z and plus z. So I just need to change the signs of one of them. So I'm going to keep equation A as it is, 3x minus 2y plus z is equal to 9. And equation C, all I'm going to do to it is change the signs. So the 2x becomes minus 2x, the 3y becomes minus 3y, the z becomes minus z, and the minus 2 becomes plus 2. So what I did was I circled my new sign so I know what the new sign is. Because sometimes if you just write down the new sign beside the original sign, you might forget which is the actual new sign. So I always circle the new sign. So plus z minus z cancel out. 3x minus 2x is x, minus 2y minus 3y is minus 5y, and 9 plus 2 is 11. So now I have a second equation in terms of x and y. So I'm going to take my two highlighted equations and I'm going to solve them simultaneously. So I have 11x plus 19y equals minus 27, and I have x minus 5y equals 11. And what I'm going to do is multiply this entire equation by 11 so that my x's match up. So I keep the top equation as it is, 11x plus 19y equals minus 27, and I write it down here. And 11 by x is 11x, 11 by minus 5y is minus 55y, 11 by 11 is 121. So now what I need to do is change the signs of one of my equations so that I can cancel out my x's. So I'm going to change the signs of my bottom equation. So 11x becomes minus 11x, minus 55y becomes plus 55y, and 121 becomes minus 121. Again, I've circled my new signs. I can now cancel out my x's, and 19y plus 55y is 74y, and minus 27 minus 121 is minus 148. And minus 148 divided by 74 is 2, so y is equal to 2. So then what I can do is substitute y is equal to 2 into one of my equations. So I'm going to go for this one here, x minus 5y equals 11. So x minus 5y equals 11. I swap the y for minus 2 with brackets around it. Always use brackets when you're doing substitution. Minus 5 by minus 2 is plus 10. And 11 minus 10 is going to be 1. So x is equal to 1. So now I have y and I have x. I'm going to substitute both of these into one of my original equations. It doesn't matter which one. I'm going to go for the top one because I'm trying to find z. So I have 3x minus 2y plus z is equal to 9. I swap the x for 1 with brackets around it. I swap the y for minus 2 with brackets around it. 3 by 1 is 3, minus 2 by minus 2 is 4. Bring down the z, the equals on the 9. 3 plus 4 is 7, so 7 plus z is equal to 9. So 9 minus 7 is 2, so z is equal to 2.